All right, so I'm the founder of AlphaPoint. We've been operating for a little over 3 years now, and we have over 20 exchanges in 15 different countries, and we power some of the largest exchanges here in the world. Essentially, we love blockchain technologies, and 2016, what we're going to be doing is, in addition to selling our exchange infrastructure, we're going to be developing a lot of interesting blockchain solutions. One of the primary topics that we're covering is asset issuance, which is actually great because it seems like some of the previous talks revolve around this asset issuance. And what this really means is let's make it easy for financial institutions or individuals to be able to create a financial asset and then to be able to trade that. So 2015 has been great for blockchain investment. As we see here, there's a lot of name brands, and there's been over $1 billion invested in blockchain type solutions. So why exactly are blockchains important? And I think fundamentally it comes down to having data replicated in multiple databases. This leads into multiple different issues. One, is the data the same across these different databases? When there's an issue and the data doesn't match, how do we reconcile the data? Who is the authoritative store? How do you propagate a change across multiple different databases that might be shared across different institutions? What's the format going to look like, especially when there's development teams at multiple different companies. So it's complicated, and it causes a lot of pain for financial institutions, and one of the biggest problems is what happens if the data is different across different databases, and what happens if these companies don't even know that the data is different. So the blockchain promise fixes a lot of that by essentially saying, hey, we all are sharing the same ledger. So some of the use cases that we anticipate are cross-border transactions, and this could either be like peer-to-peer payments or essentially intercompany transfers, IOUs, clearing and settlement for a variety of different types of contracts, anything ranging from equities to commodities to over-the-counter stuff. Issuance and management of various different private equities or custom products. And essentially anything that is a contract can be represented on a blockchain as an asset, and not only can it be transferred, but it can also be morphed. So as you've heard from some of the previous speaks about smart contracts, and these are simply contracts that have variables associated with them, and they can essentially change over time. And everyone that wants to view that contract can see the current state plus the history and why these changes happened. Okay, so we've identified that there's 3 different types of blockchains, and this is still early space, so we might see some evolution from this. But essentially, a public blockchain is like Bitcoin, and what this means is all the data and actions is visible to everyone. There's no secrecy. There's no kind of hidden information in the transactions. You still have the notion of private key, so the owner of an account has control over his funds, but whenever an action happens, or if he wants to essentially put information in there, that's public and exposed to everyone. A private blockchain is a little different, where there's only a known set of parties that can actually join the blockchain, and only those parties can see the information that's going on. A little bit more advanced version of that allows for individually encrypted messages, and then only groups of parties in the blockchain network can see those messages. And then a little bit more advanced version of that is you take messages and then you piecemeal them, where you have a public component and then one or more private components where different groups can see different information. And a great example of this is, for instance, in an exchange business, you may want to know certain information about the counterparty. You as, let's say, a counterparty trader may want to know certain information about the counterparty, like an anonymous identification, but there may be legal restrictions around you knowing, for instance, all of the information, all the KYC or account information associated with that individual. So in this case, what you would probably have is a combination of some public component of the message that explains, hey, here's the public trade, and then some private component of the message that says, hey, here's some further details how perhaps a compliance department or an auditing agency or a government agency can do an investigation if they need to. So here's an example that we came up with that's kind of complicated today. And essentially it's how loans work. And you can have a lender, and a lender can essentially offer up a contract to be purchased by a borrower. And then this specific contract may be split up, publicly traded or privately traded, and then transferred to different individuals. And examples of this are essentially like mortgage-backed securities. So it becomes difficult to kind of track who owns this contract and where is the latest version of this contract in the current day system. So what we propose is essentially removing the centralized systems and replacing that with the network. And now you can always refer to the network, and all the parties involved in the network actually store all the data. So anyone that's interested in this not going sour is going to host a full node, and that's how the data stays intact. We believe that this is going to be able to increase automation a lot. So for instance, you'd be able to subscribe to an event. So if you're interested in a particular asset or asset class, you may be able to write a script that says, hey, whenever such event happens on this network, notify me. And then this can trigger other events, which then can lead to messages being thrown back into the blockchain. And a lot of different business processes can be just strictly automated. And this is anything from certain onboarding procedures or certain actions that need to result due to a previous action, like purchasing of a contract. As an example, an entire settlement script can be executed by a third-party agency as soon as an asset that they're interested in is traded. And obviously we have more efficiency and auditability, which is a great thing to kind of prevent consumer fraud. So what we're doing here at Alpha Point this year is we're building a general purpose blockchain database. And what this means is we're targeting rapid application development. We don't think that it's necessary for every developer that wants to create a new blockchain solution to kind of build the guts from the ground up. So we're essentially creating the groundwork layers, and our first application is going to be asset issuance, but since this is an open platform, anyone can build any blockchain application on top. And I think in time we'll see that not only will financial applications be decentralized, but we're also going to see a lot of kind of consumer products become decentralized. Everything from Wikipedia to Reddit will also be decentralized. So that's it. Let's see. Okay, great. So I still have a few minutes, so I'd like to open the forum up for questions. Again, I'm Joe Ventura, and are there any questions?